This is a bot that I built to play and complete the video game I'm on Observation Duty 6, a game that I found in the discount bin at Walmart. So before we get into why I built this or how it works, we need to talk about how the game works. So it's basically spot the difference. You look through these cameras and then you find things that change and then you report them. And that's pretty much the entire basis of the game. It's very simple, but they get you in these special case events, which are not so bad if you're a human player, but provide more of a challenge for a bot. Why did I decide to make a bot to automate this game? Well, I figured that this game would be easy enough to make a bot to automate, but also dynamic enough that I'd have to make something a bit more challenging than my last one. Now, this is also some indie game made by, I believe, a one-person developer, and it is honestly a bit of a factory farm. The games are very simplistic, but the main reason that I chose this game over the other ones is this is the only game that allows you to actually click on the anomalies to report them. The other reason I decided to automate this game is because each level takes 30 minutes to complete. That's 30 minutes, and you only get 3 errors and the game ends, and you have to start over from the beginning. So really in the long run, I'm saving time by making this bot and having it play the game for me. So if you're going to solve this game, you might just ask, why not just take screenshots of the rooms and then compare them? Well, can you tell me the difference between these two images? What about these two images? Or how about this one? And if you're able to get those 3, tell me the difference between these images, but go walk away and do something else while you're doing it. The second most simple solution to this would be to just find a Steam guide and get a vision system to recognize every different anomaly that's in the game. Now, this would be tedious and take forever, but most importantly, it would never be able to apply to anything else. The other option would be to take a screenshot of the game, divide it into sections, and get values for each section. So how does this bot actually work? Well, it takes the base image of each camera for each level. So when each level starts, the first 15 minutes of game time, nothing happens. So it has that time to check and evaluate. Once it has these base images, it loops around several times to find what the difference value is. Now, this game doesn't use still images. They are 3D environments, so sometimes there are things that move around slightly. 2 different images will not be exactly the same. Now, once the game begins, it will start to scroll through each of the cameras and take a full evaluation of it. Now, originally this bot was made to simply point out where the anomaly is, but that still requires a lot of work on the user. So I have also given it autonomy to scroll through the cameras and report itself. Unfortunately for that idea, there are plenty of special cases that are coded into the game. So how does this bot actually work? The bot was built in Microsoft Visual Studio. It uses the Windows H tools to actually control the mouse and keyboard and listen for commands. It also uses the OpenCV library. OpenCV isn't exactly an easy import. You have to install it, and then at least in Visual Studio, I had to find the library and link it with the project, which was a bit of a pain to get right. There's probably easier ways to get it to run. And OpenCV is a bunch of tools for vision, and we'll be mostly using that for screenshots. So how does the script actually work? Well, the bulk of the OpenCV is used in this first function. So the arguments of this function are the x and y and width and height of the image. This one I don't usually use in this project. I just have it set to my screen size, but I can change it if I need to. This other argument is the name for the output file for debugging purposes. In this first part here, it takes a screenshot and converts it to a map, which is sort of a more efficient way to hold images so OpenCV can actually work with them. Then it converts it to grayscale. After the conversion, It divides the image into 10,024 sections. That's 32 by 32. It gets the average value of each of those sections and stores them to an array. Now in each map, it takes 15 minutes of the in-game clock for anything to actually happen. So the way this bot knows what to ignore is it goes through every map in the first 15 minutes, which is about 3 or 5 actual minutes, and it takes screenshots of each room multiple times, comparing these values against each other. Each room has its own array of values. These are numbers from 0 to 255. So now you want to check for anomalies in the room. The function goes through each value on the reference and screenshot grid, calculating the difference between them, and takes the absolute value. This is the specific value for that section. Now there is a constant called the diff. The diff is a constant threshold. The final value needs to be above to be recognized as an anomaly. The other thing to mention here is this if. This just takes all the sections covering the clock and grays them out. Now most of the anomalies in this game you can just click on and they report. However, there are still some special cases, and that is a big wrench in this project. One other thing to note is that this is an earlier version of the bot, and it is playing the game in hard mode. And hard mode with this game only allows you 3 wrong attempts at reporting something. And when you hit a 3rd attempt, it will stop you from doing anything for about 30 seconds. It's likely because I was doing all the testing on this map that I ended up getting lucky. However, I could not get hard mode to work on any of the other maps. As you can see here, there are some anomalies that require opening the menu to report them. The bot is not able to actually recognize anything. It can only see that something is different. So it will attempt to report something, and if it doesn't succeed, it will start going through the menus and report them one by one. Now the way this version works is it will run around the rooms before making another attempt. This has changed in a later version, but either way I still could not get hard mode to work. The problem is not dealing with these special cases. The problem, however, is when I get 2 special cases. Sometimes the time it takes to deal with one is the time it takes for 2 more anomalies to show up. So I'll be waiting for the bot to go report 1 anomaly, and then it will finish, and then the game will end. So all the other levels are completed in normal mode. So after it submits an anomaly, how does it know if it got it right or not? This function here checks the result. It doesn't need to be checked against anything, but it will use the regular screenshot function. When there is a successful anomaly report, the screen goes mostly black, and when there is a blue screen, the screen goes to the same shade of blue. So it just takes every value and sees if the value is less than 10 for the black, or if it equals 54 for the blue. If 3/4 of the screen is seen as blue, it'll return the blue screen. If 3/4 is seen as black, it'll return that the anomaly is fixed. In all other cases, we know that it's not fixed. So the way that the original bot worked was it would take the images and then it would have one constant value of the diff. Whenever anything was checked with this bot, it was checked against the diff, which would stay the same for each room. When allowing the bot to make all the decisions, it wasn't enough to just have one value for all of the room. This level doesn't showcase it exactly well, but you'll see as the levels get less stable how much more difficulty there was getting the bot to recognize the background from the anomalies. So now we'll talk a bit about the startup of the bot. The bot opens and it runs a command line. It waits to read keys so that it can be commanded while in the other application. You select the automatic mode and select the level. This will select the number of cameras that it uses. So now I recorded the diff value for each room, but how do I actually know what the value is that I need to use. The bot starts by taking an image of each room, and then it loops through it multiple times, finding what the highest difference is in each room. If you see at the right-hand corner, you can see it scanning, and it gives the value of the highest difference for each room. Now that's the highest difference plus a little extra threshold. Now it makes this game a bit more difficult is that these are not just still images. Everything in the scene is rendered, so that gives a lot more things that can throw the bot off. So there's three main things that can cause differences between scenes. Those are anomalies, things moving in the background, such as the clock, and the static. You may not have noticed it, but there is a static effect in front of all of the cameras in the game. This effect varies a lot, and it has a large effect on the bot's ability to reason. You'll see sometimes, I believe especially at the end of this recording, that in one of the cameras, it will start clicking on a part of the wall for no reason. After it finishes scanning the rooms, it will then enter the main loop for the rest of the game. Now when in time it spots an anomaly, it will click on it and report it. So how does it actually know where to click? It uses this function here, find the anomaly. It takes in the index, which is the room number, and the value of the diff for the room. Now it takes a screenshot and it goes through each value, comparing it against the original image. It will count how many values are above the diff, and it will find the value of the largest difference. Ideally, if something is changed between the images, the center of the anomaly will have the highest change. Now this doesn't always exactly work, and it can lead to problems. Now there's a small amount of math to it. Basically how it works is the values are stored in a vector, which is basically an array. So you just have a straight line of numbers to represent the string. So in order to get the correct two-dimensional position to compare it to, you have to take the position in the array and get the modulus and division by 32 to get the x and y. Then those values are multiplied by constants to get the actual position on the screen. And then they're added the width and height of one of these sections so that it'll click in the middle of the section. That's why as you see the mouse move to the top corner to get out of the way, if it doesn't find anything, it'll actually move down slightly. That's that adjustment. There is one other thing that this function does before it returns its value. Each room has another array of positions that is already tried. In this game, an anomaly will not happen twice on the same playthrough. Each time an anomaly is checked for and it thinks it found something, it will take that highest value and it will save it to an array. This value, if found again, will be ignored. This comes useful later in levels where the max difference isn't found exactly right and still tries to click on nothing. Even though it still makes a mistake, it will only make that same mistake once. This is also partly why the sections of the screen is so big. Ideally, you would make each section of the screen smaller and smaller to get better results. But this would only work if the sections had some relation to each other, which in this script they don't. The problem with saving these positions is sometimes the position will be saved when checking for a special case. Even though it's not clicking on it, it'll still save the position it finds of the highest difference to this array and ignore it. The size of the sections are still small enough that usually it will be able to find the anomaly even after a few ignored positions are stored. There are three parameters that are returned when this function is run. This function not only finds the highest value of the anomaly, but it also finds how many anomalies were found on the screen. There are two types of anomalies that relate to this first one. Those are distortion and camera malfunction. Distortion is exactly how it sounds. The camera will distort and the bot will no longer be able to recognize it because of the movement. The second condition is a camera malfunction. This is priority number one for the bot to deal with because the bot can't figure out exactly where it is. It only keeps track of where it is based on how many times it's moved. The way a camera malfunction works in the game is the camera disappears and the player doesn't know about it. However, this will cause the bot to see every room as an anomaly, so this needs to be corrected immediately as it happens. The second condition is a normal anomaly, so this is the general case for everything, and the other case is no anomaly. This There's an interesting bit of luck here. I don't know exactly how it caught this, but it should be ignoring this clock since it moves throughout the whole game. However, it started moving backwards, and the bot was able to figure it out and click on it. It was also a very forgiving position of the area that needed to be clicked. Sometimes there will be an anomaly such as an object movement, where an object will move from one area to another, and instead of clicking on the place it moved, the bot will click on the place that it was previously, as both are seen as differences. This may not be accepted. Another thing that you may see is that the bot will sometimes randomly select the bottom right of the screen. It doesn't show up in the recording, but this is due to Steam notifications. I was going to shut them off, but they were good error testing, and I never got around to it. Speaking of error testing, this bot was insanely hard to get working whenever anything was changed. But the way the bot keeps track of rooms, anything that it does, it has to be able to do. However, anytime an anomaly is fixed or some special cases arise, the bot will be stuck and then it will get lost. There's also the condition where it gives a false positive. It will look and report something and it will tell it that there are no anomalies found. If the timing is not right, then it will check again when the text shows up and it will turn into a loop because it will think that there is an anomaly there. The way that this game works is that there only need to be 3 anomalies active for you to lose. It might sound like there's a lot of leeway, but as the game goes on, these anomalies can show up exceedingly rapidly. Even when the bot is busy doing something, 2 anomalies may show up that it won't even get to. This forces a need for the bot to move fast and be efficient. Anytime the bot performs an action or checks something, it needs to spend the least amount of time to do it. So let's go over how the main loop works. As the loop starts, the index increases. The loop is run through once for every room. Now you may look through this and say that there's a lot to it, but most of it is just dealing with special cases. The bot is perfectly able to handle with normal anomalies and the regular special case anomalies. However, this game also has characters. Not only will they break the routine by showing up after an anomaly is successfully reported, but they'll also freeze the camera in place, and it can also cause the camera to move towards them. Now the bot is stuck not knowing where it is. Now while I may have made ways to automate everything else, these character anomalies are especially rare and unique. There's no perfect way to deal with all of them in the same way. Since the level and camera number is always kept track of, I can just make cases in the code to deal with them. It seems a bit lazy, but at this point I just wanted to complete the project as testing takes way too long, especially when one of these cases appears. Everything will be going fine until the last hour of the game, and then when one of these characters will appear, it won't be able to deal with it correctly and lose the game. The only way to test for that specific anomaly is to wait for it to randomly show up again. In our program, the loop starts with finding an anomaly for the room, and it will check the result of the last room. The reason it does it in this order is because of the timing. Since the time it takes doing any operation is so important, it will scan one room, and if it finds an anomaly, it will report it. Before the report completes, it will switch to the next room and take the screenshot of that room. Now it has a screenshot of the next room, and only then, after that calculates, will the result of the last report come in. There is about a 160 millisecond window to make sure that no UI elements appear in the screenshot. When it runs the find anomaly function, the screenshot is taken as a full image and is then broken down. This way, the program can work with consistent data. It then needs to check the result because if the anomaly is successfully found from the last room, it will need to wait for the black screen. The bot then needs to deal with case 2 anomalies. This is where the entire room is not correct. First thing it considers is a missing room. Now it has to go through the menus to report these anomalies, as there's nothing to click on. Whenever it reports something from the menu, it always goes to the top left corner. That is the origin point for the screen. Keeping it consistent this way makes it so that I can give it similar commands for different rooms, since it will adjust itself. If it finds that there's a missing room, it will report it and then wait to find if it's correct. If it's correct, it has to shift the position that it's in. The other possibility it checks for is a distortion of the camera. This can be a dangerous one for it, as it won't be able to recognize where it is. Also, depending on the map, some distortions may cause the camera to freeze. In addition to that, some of the distortions start in the normal place of the camera. Since the screenshot is taken exactly at the moment that the camera switches over, sometimes it will come across a distortion but not be able to recognize it because it hadn't moved enough yet. Since that freezes the camera, it causes the bot to get lost. Next, it checks for regular anomalies. The find anomaly function doesn't actually return any position data. It only returns if it found something. The function itself moves the mouse. If a normal anomaly is found, all it needs to do is decide to click. After it clicks, it checks the result. As long as the result is correct, it will wait for the anomaly to fix itself and move on to the next room. Now there are three main types of anomalies that cannot be reported normally. These are abyss, light, and ghost. Ghost anomalies don't allow you to click them for no reason. Light anomalies usually encompass the whole room. This can be odd to deal with because sometimes they will false positive as an entire room anomaly. Sometimes they can be clicked on to fix, but this is usually if it's within a lamp or something like that. Abyss anomalies are also not allowed to be clicked on. Abysses are these gelatinous black masses that show up and slowly engulf the room. The problem is, you want to be able to catch them immediately as they start, because the next time it goes to the room, the abyss will have filled the entire thing, and will be seen as a full room anomaly. It may also recognize the screen being black as it's successfully reporting, which could cause it to get lost. Whenever these special cases are found, it will go through one by one, checking to see if it was correct or not. If it gets through all the cases and none of them work, it will no longer attempt these cases for that room until an anomaly is fixed. As you can see here, there's a lighting anomaly, but it was still allowed to be corrected normally. You can see that whenever it reports anything in the bar, it'll make a false report in the middle. That's one of those special cases that it responds to. Sometimes there'll be a guy that appears in the bar after you fix one of the anomalies, but it does lead to wasted time, which is why I don't like fixing things like that. I had now completed 3 out of the 6 maps for the game. However, once I got to this one, the limitations of the bot started to come out. A lot of this was shown mostly in the outdoor area, where there's a rolling fog that goes through it. Now, I tried a few tricks. I tried to see if I could flip cameras back and forth to see if maybe the animation will reset or something like that. But the way that this game tortures my computer tells me that it's probably running everything all at once and is completely unoptimized. And despite being mostly still images, all of the cameras in this game are completely random if they have any sort of movement in them. So this was a bit of a problem. Now, I had a few ideas of how to deal with this. I think the best idea I had was, since I had the diff value for each room, why don't I have the diff value for each section of each room? But this seemed a bit excessive to me, and I didn't really want to go through with that route. So what I ended up doing is I made a constant max value, and when it did the original run through of the cameras, if anything was above that max value, it would be added to the ignore list of that camera. Now that only works so well. As you can see, it still has some parts of it that change more than it saw originally. I did have some ideas of how to deal with this. I was thinking about capturing basically a video amount of screenshots from each scene, just holding on them one by one. However, some animations for some scenes took longer to loop than it would for the anomalies to start showing out, so that idea wasn't exactly perfect. So I just stuck with the looping around, and I just gave it a bit more loops before it started the main routine, and that gave it more samples to work with. Now this room here also has a special case in it, so if you read at the top right, you can see the output from the bot. As it runs, it will say which output result it gets, and also which check result it gets. When it finds an anomaly, it will give the position of each one. Now, these ones are only the maximum values found. So if it finds an anomaly of one value and finds another anomaly of a smaller value, it will only list the larger one. Whenever it is going to check a special case, it will list it out to the prompt. We now found a really big problem in how the bot actually works and thinks versus how a person would see this scene. Now look at the library. Are you able to find what the anomaly is? The bot is having a hard time with it. So the bot excels really well at finding small things. If one object is moved from one place to another, it is really good at seeing things that a person wouldn't remember or even notice. However, something big that appears and it's very noticeable, you'll notice it and you'll be able to recognize exactly where it is. However, in the scene, the bot doesn't know what things look like. It doesn't recognize anything. Even the sections of the screen have no relation to each other. So if you haven't noticed it, the entire window on the left is completely disappeared. So not only is the entire wall different, but also the light coming from the window is missing as well. So now that's just a huge section of the screen that's completely different. And the problem is, since the lit up floor versus the non-lit floor has a bigger difference than the slightly bright brick wall versus the dark window, the bot tries tens of different positions before it even begins to consider the wall. So this is another reason that I was not able to get through hard mode with the bot as it is now. Even if it ran into this anomaly, it may be able to handle it, but if it had a second anomaly, it would be taking this time in this room each time it goes around. And if there was some other special case, which are plenty in this map, then I would not be able to get through it. So now you can see how some of these special characters look when they appear. Even though there was a successful report, he still comes in and then the camera changes and it's stuck there. You're not able to move away from the camera. Now there probably should be some check to see if it's already tried these special cases or put all the special cases into one function just to keep them organized. But as I was saying, I was trying to finish this project so I could move on to other ones and have something to show. You can see the level is almost over and it still was not able to catch that one anomaly. It should also be pointed out that two anomalies will not show up in the same room at the same time. So this does allow some leeway for the bot. It at least won't get too confused. I had also considered using that as a tactic for some of the special cases. If you just completely ignore a room and wait for it to get an anomaly, it will just stay there for the entire game and then you'll never have to deal with it. Although that's a bit risky because now instead of having 3 anomalies catch, you have to catch 2 at all time. Now this here is a distortion, although this one doesn't require a special case because it doesn't lock the camera in place. I'm not sure exactly what the reasoning is between which distortions cause the camera to stay and which ones don't. These special case distortions have a specific sound effect to them, and if you don't report them soon enough, it will lose the game instantly. So this level is basically completed, and it had a lot of challenges for the bot to get past, but this next level is a completely different ball game and was a giant problem for this project. Summer Cottage. This ambient noise plays in my dreams. This took way too long to get down. You may notice that the bot acts a bit differently and the output lines are formatted a bit differently. So what's going on here? So this is now running the final version of the program, and there's still a lot of things that I would have liked to tweak with it, but this is where I'm keeping it. Now, if I've explained well enough how the spot works, you may see the problem with this map, and that problem is that pretty much every camera in this map has a large section that moves around. And what this means for me is that there are giant swaths of areas that the bot will find as anomalies and give false positives everywhere. So how did I get around this? Well, do you remember when I was talking about giving each section its own the diff value and saying I didn't want to do that because it would be too inefficient and it'd store too much? Well, it's too bad because that's what I did. So now each section of each camera has its own value that it stores. So when it goes through the initial loop, it will find a different minimum value for each section. And originally when I did this, I was expecting this to just work perfectly and to not have any problems whatsoever going forward, but that was not at all how it turned out. As I was saying with the outside camera in university, all the animations happen all at the same time throughout the game, or at least I assume they do. So there's no way to catch them in a loop or anything like that. So even though I give it many samples in the beginning, it's still not enough. It's not perfect. So what I ended up doing is changing slightly the way that the diff value is calculated. It starts every diff value at 0, and it takes the base readings. It finds the difference for each pixel, and that is its own value. That value is then added 1, and that new value is squared, and then the 1 is taken away again. This way, it can get the square of the value, but if the value is less than 1, say 0.25, it won't turn into a value lower. It will still raise in value exponentially. I also tweaked what it took away a bit. So now, even if it sees a tree branch come slightly into the frame, it will raise the diff value a lot larger than if it was just a static effect on the same area. It also gets rid of the need for a maximum value. Now, if the value is too high, it will just exponentially raise, and ideally, it will never be able to reach that point, unless of course there is an actual anomaly that happens on that spot. You may also notice that it will pause at the kitchen whenever it opens it. This is because the kitchen has one of these special case distortions. However, the distortion starts on the normal position, so there will be no way for the bot to realize that it's stuck in it. So in order to fix this, I just let it pause at the kitchen for a bit. The problem, of course, is that this goes against the objective of getting through the cameras as fast as possible. As we can see, the bot was able to catch the distortion. It only needed a second for it to be able to differentiate it. There is one more special case in this level that I'm a bit disappointed that didn't appear and it didn't get to catch. But there is one character that appears in some bushes in the doc's camera. And if you don't catch it fast enough, it appears on the camera and ends the game immediately. So it's a bit sad that I wasn't able to see it reported, because I'm not sure if it would have actually been able to get it. So now that had finally been done, I was able to get past the hardest level for my bot to complete. So now after this, I was ready to do one victory lap around the last level. Now, when I say victory lap, what I mean was I thought this was going to be a victory lap. So before I went through this level with the final code, I had previously tried a level before with the earlier code that didn't save difference values for each pixel. So I assumed that this would work better because when I did it earlier, I did it on hard mode and nearly got through it except for one of the special cases. So I figured that now that it's more sophisticated, I should have had a way easier time to get through it. But it seems like I got lucky before, and that luck did not come back at all. So the first problem was that the sauna room just did not want to play nice with it at all. Even though it ignores places that it's seen, it still at random times will decide that it doesn't like something in the sauna and it will just report it randomly. This one here, I'm not even sure what happened. I probably could have gotten away with cranking up the brightness or something just to get more contrast on it. I am surprised how well it's able to handle things in the pool though, since there is a lot of movement in there. Even underwater has some normal distortion that goes back and forth, so it's interesting to see that it can get around it sometimes. Looking back at it now, the brightness, especially the contrast of the objects in the map, definitely have a lot of importance in how well this bot works. It's almost as if it has a sort of bandwidth. So even these lights that the camera looks directly at, and those I doubt have a value of 255 or anything even near there, especially when their value is taken with the average of the area around them. Honestly, I'm impressed with how well this bot works, despite its many flaws. Now that one might look impressive, but that clock never actually moves. At the point I was recording this, I was just ready to be done with this project, and I was pretty relieved to see that it was finally getting through this one. And with that, my bot had completed the last level and I'm on observation duty 6. I had enjoyed making this bot, but it was time for me to move on to other projects. If you're interested in any more of this bot, the code can be found on GitHub, and in the description you can find the raw video of the entire playthrough.